Okay, good morning. I hope you had a nice long weekend. So what I want to do today is a bit of introduction, first to Git and then to databases. There is a homework one posted, as you all should know. It's due Thursday, okay? And there is a draft of homework 2, which is not final yet. We'll finalize it today or tomorrow. That will be due next Wednesday instead, okay? And homework 3 draft, I don't know, I will post it some of these days. I know what I want to do roughly, but I want to see the least painful way to do it. So, you know, the most neatest possible implementation of that. Okay, so is there any question or any comments? How many of you know Git or have used Git? Not so many. So I mean, a few yes, but many no. So the reason I go into Git, it does not have particularly to do with web design. Okay, it could be done in fact, I also talk about Git in my Android class. But basically nowadays, when you write code with others in an industrial environment, that means outside of school, you always version the code. And I'm noticing more and more that the ability of people to keep straight what they do inside versioning systems is not a very small part of their performance at work and how much they're appreciated by others. Okay, if you commit code, if you build your code in a clean way, you can always tell others, oh, that thing I'm doing is there and that other thing is there, and you know, you can use either one of the two, and you're very orderly in what you do. Everybody appreciates it. And the people who are maybe great coders but make a mess of how they organize their contributions, they mix different things into the same stuff they're writing, so that you cannot use one thing without using everything they're writing. Those people are generally not very appreciated. So it's becoming really an important factor in really success outside of school using these tools. Okay, so there are many versioning tools. You know, CVS, CSV, CVS. CVS used to be the most famous one once upon a time. And CVS was sort of fine, but had several drawbacks. Essentially, it versioned each file independently rather than taking a whole snapshot of your directories. So after that, SVN was the one in most widespread use for a while. Okay, and SVN enables you to take a snapshot of a whole directory. So that's really good. Okay, so if you work on multiple files and if you are at a point in which you believe your code works, you can say SVN commit or check-in, I forgot, SVN commit, I believe, of your directory. This would associate a number to your commit and a commit message, and everybody could pull it in their code. And this works really well, except that SVN implements really poorly branches, okay? And now I'll tell you what branches are. And Git essentially has two properties that make it loved by a lot of people. One is that it's easy to do branches, and the other one is that it's decentralized, meaning that the older repositories, CVS or SVN, had this notion that there was a repository, and you were a poor person. You weren't on the repository yourself, of course. So you just had, you know, a checkout of the current repository. But if you wanted to browse the history of what went on in the project, etc., you had to access the repository, which meant that if you were at the beach or on an airplane or, you know, taking a bath or, you know, all these situations where we actually get work done, you couldn't access the repository. The other problem was that if the repository died, you lost a lot of information. So then suddenly you had to worry really about backing up the repository. Instead, in Git, every person that checks out and contributes to the project has a full copy of all the history. So if I say work with my TA and my laptop dies, well, no problem. I mean, I have other problems, but not the problem of the shared repository, because his copy of the repository is as good as mine, is as good as any. So not only you share the code, but you also distribute where the code resides in such a way that you can easily recover from trouble. And that's really a great feature. I mean, it has many other great features, but So let me first tell you a bit about the theory of code version. I mean, it's unbelievable. There are people that really do research in this. Actually, my lectures are recorded on YouTube, so maybe I shouldn't make these funny assertions. But so you start your project, and I draw these points as points, I guess. But these are really commits. So these are snapshots of your whole directory tree in which you're actually working. Okay. You don't need every file to be inside a repo to be versioned. Okay, in particular, there is a file called gitignore. Gitignore. You saw me set it up, and there is a prototype gitignore file in your resources in the class web page. Okay, but if you put a .gitignore at the top level of your directory tree, this will specify which types of files should never be versioned. Okay, so for example, backup files or binary files that you obtain by compiling something else, that kind of stuff shouldn't be versioned. Okay, because I mean, it would just when I see what is the decision of what to version and what not. Essentially, you want to make sure that if I look at the files you changed, I can make sense of it. So I want I want to see the changes you do to source files, and I want to see the changes you do to, say, images, because images are also important. But I don't want you to, version the binary compiled version of some piece of code, because I can care less that you actually recompiled it and now it looks a little bit different. I want to have the change to the source code that I can actually look at. So you essentially should version the ingredients, not the result. Okay, so you make a version. Okay, then you can work on some files, and you make a subsequent version. You work some more, and you make a subsequent version. Okay, fine. That looks very interesting. And so you can go back in time if you do something stupid, and you can also see if here it works and here it's broken. You can look at the diff between these two, and you can try to figure out which one of your changes actually broke it, which is pretty useful. Sometimes the sequence is 10 long. It happened to me more than once, so that sometimes I made a sequence of 10 of these commits, and I broke something that I wasn't paying attention to. And then luckily I had this history, because it was really difficult in those cases to figure out what broke what. I've had some very, very obscure bugs that I think without versioning my code, I would never have been able to find. So this is fine as long as you work alone. And there is a branch called master, okay, which is a sort of the default branch. Every versioning system calls it a different way. In SVN it was called trunk, in Git is called master. Okay, so that's the master branch. The idea, the master branch is the consensus working state of your project. Okay, so using versioning systems is very much a social thing, right? I mean, there is no right way to use them. You simply have to agree with your co-workers on how to use them. So the usual convention is that master represents the consensus. So how do I work on it in practice? I work on it this way. Suppose that somebody tells me, Luca, wouldn't it be wonderful if in CodeGrader, say, you implemented this feature that enabled everybody to get one more point when they do a homework? And they say, yeah, great, okay, let me try to implement that feature. So then I create a branch. I will tell you how you have to do it, but now I want to focus on what I do. Okay, I always name my branches Luca dash something. Okay, so this would be Luca dash like plus point. Okay, this can be one of my branches, and maybe it takes me 2 commits in order to figure out how to do what you asked me to do. Then, suppose there's another person that tells me, oh, Luca, this thing here is broken. Can you please fix it? I'm always in, say, CodeGrader, okay? So fine. And I do a branch that is, maybe I call Luca fix 1, okay? And in the meantime, there is another one of us that, for brevity, I call, I don't know, Anna, in spelled Italian way. And she's working on, I don't know, on mobile, on something that makes it better look for mobile. Okay, so we have these branches, but the important thing is that if I work on very independent features, I try to do it in separate branches so that, you know, if Anna then decides, okay, I want this plus point contribution, but I think you did a really bad job with the fix one, she can actually decide together with me to merge this change into master, but not the other one, okay? So this is sort of the sophisticated way of working. Sometimes I just work in a single Luca branch, but if you work in a more sophisticated way with on a more serious project, you want to keep especially the far-fetched experimental stuff in a separate branch, so that if you figure out that it really doesn't work, you don't want to have this you know, this stupid idea of doing a plus point to everybody who does a homework mixed with a very important fix. You want to be able to get the fix inside master, but not necessarily the other thing. You know, these branches essentially give you the unit of contribution, because it's easy then to merge the changes in a branch back into master. For example, in a single command, I can merge this Anna mob into master. Okay, the command is actually that I go to master. I will show you, and I say merge Anna dash mob. Okay, something like that. So it's very easy to merge different changes done by other people back into the master branch. Okay, and after this happens, you know, we can decide, for example, that this is a dead branch because it was a bad idea. So it simply stays there. You know, nothing happens to it. But instead, we decided to merge this fix inside master and go on. So typically, if you look at one of my repositories for in which I'm doing actually real work, there will be a master branch, and that master branch usually evolves a little bit by consensus. So at some point we say, you know, hey, this feature is ready, you know, we tested it enough. Shall we merge it in? Yes. You know, it depends on your style of working with other people, but sometimes it's pretty informal to merge into master, and sometimes instead it's a big decision in which you really tell everybody and you say, we're doing a revision. I mean, we did a lot of testing of this code, and here is the reason. You ask your friends to review your code, which is always a good idea, and only then you merge it in. Okay? Now, the beautiful thing, so in general, I have my Luca branches, I have the master branch, and often I have branches of my coworkers so that I can go look what they are doing. Okay? The other very nice thing is that you can always go work in somebody else's branch. So, for example, there is this AnnaMob branch. If I want, I can go move to this branch. I will show you how, and I can basically run the code under this branch. So, if I want to see, suppose you know that this is a new UI, like this branch is supposed to be, and suppose that she tells me, "Okay, I'm done. You know, okay, do you like it?" Well, fine. I can take her branch. I can go work in her branch. I can run Web2Py in her branch, and I can see, you know, what UI she has done. Okay, and then I can essentially fold it back. Now, this way of splitting up the work works really well if you touch different files. This is the case sometimes. No, for example, you can say, well, you do the new UI and you work basically on HTML and CSS, but I'm instead working on this, you know, backend featuring, which I will work on this and that controller. Okay, this works without any trouble, because if the difference here and the difference there involve different files, it's kind of obvious how to merge them back. Okay, if instead you are working on the same file, when you merge the changes, there is the possibility that you get some conflicts. Okay, so you change the same section of the file in one way in one branch and in another way in another branch. When you put together the two changes, Git doesn't know what to do. In that case, it tells you that there is a conflict, and it tells you that you have to manually produce a unified version of the code. Okay, so really there is a bit of the social and a bit of the technology. The technology gives you the ability to have these separate branches and to merge them back in, etc. And I will give you now an example. The social involves various things. It involves, you know, agreeing on who works on what. Okay, trying to organize the contributions so that you don't step onto each other's feet all the time. No, try to make it so that you know, I can do some work while another person can do some other work, and we don't interfere so much in changing common stuff. As you know, this really is part of how you organize your project. No, for example, if you decide that okay, we're building a site and there are you know, pages to upload, view, and rate photographs, and the pages to instead I don't know, draw paths on maps. If you put these two things in different controllers, then you will avoid stepping on each other's feet, you know, much better than if you mixed this in a single controller, right? So there is a bit of the social in dividing the work, and there is also a little bit of the social, actually a great deal of the social on communication. So the revision systems never solve the communication portion, right? You still have to tell your friends, okay, this is what I did. It's in this branch. I think it's ready to merge. What do you think? Then they tell you yes or no, and then you decide. Okay, and if you work with others, by the way, another instrument that is really changing the way I work with others. I just mentioned it now, but I think you all know. But is this Google Hangouts, not used as I do now to broadcast. But you can look at the code and you can share the screen. Okay, so if some of you are considering working in groups, even if you don't meet, you can simply talk about the code either by looking at your version or by sharing the window in which you are looking at the code, in which case you can also, you know, you can see the other person's mouse. You can say, look, here, you know, you're really doing it poorly, you know, fix it, I don't know, something like that. Or maybe, you know, more encouraging messages, as you like. But essentially it works well, okay? So now I want, with the help of the TA, to try to give you a simple example. So, okay. So when you work with others, in theory, the good old idea of Linus Torvalds. So Linus Torvalds was a person that sort of was instrumental in starting Git, even though, you know, a lot of the code is by his group of collaborators. Some of his idea was this, that this was to be, let's say, an anarchic revision system in which distributed is the right word, right? But essentially everybody has the full version of it. And so I would work by, you know, putting a version on my computer, and then, you know, somebody else would put a version on their computer, and via, you know, SSH into each other or other ways, we would essentially pull from each other repositories. This was theory number one. And theory number two used to be that you otherwise send by email some patches that are these files that describe how your code should be changed. Neither of the two ideas is very much used nowadays. You know, the way people do is that they use an online repository, and there are various that work well. There is one of them is GitHub, okay. Another one is Bitbucket, okay. And you can also set up your own, if you like, on any host that has SSH on it. I'm sort of not particularly encouraging to set up your own, because you have to know what you're doing, and maybe you're in a hurry already, okay? Now, I was told, and I believe it's true, that Bitbucket gives you the possibility of having private repositories that is only you and your friends can look at the code for free. Okay, I don't know exactly, but so if someone of you can investigate Bitbucket, what it gives you, I think it would be a good idea. I think that GitHub does it if you are a student. Okay, so I think that if you search for GitHub student, okay, developer pack, you can sign in via these. And what does it give you? I'm not quite sure. Micro accounts. Normally they're $7 a month. So you have five private repositories, okay, that you can host, which is enough for this class and for maybe one more or two. Okay. Again, there is also. Yeah, I don't know. Maybe I don't know what Bitbucket does for students. Yeah, so he says free for up to 5 users, etc. So I mean, they're both good actually. You know, GitHub is a little bit better known, but in the end, one of the beauties is that you don't really care immensely about you know, the repository being very stable. In a sense, when I trust GitHub, I don't care that if they lost my code, because anyway I have a copy and everybody I work with has a copy. The real problem is if somebody hacks into it for code that I don't want to be released. Okay, but I don't know. I think they're both good. GitHub also has some. You know, an issue tracker that can help you track what are the bugs in your code. You can you know, open a new issue so that you can remember to fix it. But Bitbucket might as well. So I don't know very well the differences. Essentially, I use whatever. Actually, I have my own as well because I version even my papers. I write my papers in LaTeX and I version them, so it's easier to collaborate with others. So I have my own repository because I, you know, would be too expensive to pay for each one of them. So now, okay, let me go here, and I think in this bboard I had started a repository. Okay, let me do a commit. So let me, before I do the commit, why do I say git commit -a? So what are the main comments? I can say git add of a file name. Okay, this would say, please, this file from now on is versioned. And I did it in the past. Now I don't have any particularly good file to say git add, but I can also say, this doesn't harm, git add controllers. This will add the whole subdirectory of controllers. Okay, they are already added, but I don't care. You know, I can always add them twice. You know, it knows. Now, if I do git commit simply, you have to be careful, because if you do git commit, you do not take the most recent snapshot. If you do git commit of a directory, you take the snapshot at the time you added things. Some people like to do this because, for example, they might have a file that is called, I don't know, junk.py, in which they keep some code. They added it, I don't know, they added it well, okay, fine. No, I don't know. I cannot give you a good example because I never do it. So I won't give you an example. So the story is, I never ever do, or I incredibly rarely do git commit. I normally say git commit -a, which means take a snapshot of the current state of every file that I added with git add. This is the most common by far thing, because, you know, it's too hard mentally a job for me to remember whatever I changed from the last commit. I might have changed, you know, 15 files for all I know. I mean, it depends on what you're doing, right? But you really don't want to depend on your good memory. The versioning is there to help you do things right, even if you don't remember, right? So I say git commit -a, and this will commit everything that I ever added to the repository in the current state. So if I do this, this tells me, you see that there is an untracked file. This means that there is a file that is not, let me magnify the font a bit. This means that there is a file that is not avoided by .gitignore. So it's a file that potentially could be versioned, okay? But that for some reason I didn't add. And so it's telling me, hey, you know, there is this untracked file there, you know, do you still want to commit? I mean, it's not asking me whether I want to commit. If I write a message now, I can commit, okay? But then I exit while leaving an empty message, because I think, in fact, this is a mistake. I should have added that file as well, okay? So I say save modified buffer no. Okay, why do I get that editor? That editor is called Nano, and I like it because it's very small. And I simply did a set env. No, what did I do? A set, I guess. I have a bunch of things here, but I think at some point I have editor is equal to Nano. Yeah, here, this line. Okay, so Nano works well. I think the default is VI. I don't like VI, but you may love VI. Okay, so that's your choice, but that's how you choose. So okay, so I need to add that view, and in fact I'm lazy, and so I will add all the views in case you know, why not? It's faster. Git commit -a. Okay, so it tells me which files I modified. I modified the default, and I added a new file called index2. Okay, and I can write a message, added the index2 view using SQL form.grid. This is what I did when I did it. Okay, so now I save this and I version it, and this tells me that it created a particular commit. So Git works in this way. Whenever it does a commit, it invents a random number. It's like a random string represented, okay, that associates with each one of these. So each one of these will have a very long random string associated with it. And that's the unique way in which Git actually tracks which commit is which, okay? So in this case, it just gives me the beginning of the string, but the real string is actually quite long, okay? Now, there are various ways to, so the people who go nuts with the Git and cannot use it are the people who don't know how to visualize what's happening in the repository. To you, I draw this beautiful drawing, okay? But how do you do it for yourself? You can do two things. One is actually a little bit painful, unfortunately. One is to install Git-K on your Mac. But Git-K is very nice. It gives me this preview in the background. I'm sorry, the font, I cannot change it. You see a very interesting tree view. It looks like a spaghetti tree because there is no branch, okay? But I can go in Git-K. If you do serious work, I really think it's the best tool ever to look at repository. It's the original one written by Linus and others, okay? So, for example, I can pick one version, and I can say, by control clicking, I can say, sorry, difference from the selected version to this, and I can see all the differences below. I'm sorry, I cannot easily change the font to make it bigger, okay? It's just to give you the idea. So I can very easily look at the difference between two versions. I can very easily do a lot of the very advanced things. I can branch. I can do a lot of other things. Otherwise, a tool that is not nearly as powerful but is easier to use is this thing that is called, where do I have it? I have too many tools. Here, Source3 by Altassian. Okay, you can also install these, and it's not nearly as powerful, but it looks prettier. Okay, so let me see if I can use these. A new version, remind me later. Okay, so here I have a few repositories already. Let me add one. Source path URL. So this tool is built in such a way that it believes that every time, well, okay. It believes that I want to check it out from GitHub. So maybe let me use it after I create a GitHub repository for this. It will be more pleasant, okay? Now, let me go to GitHub and create a repository for this for this code I'm writing, okay? So I go to my GitHub account, okay? And I create a new repository, CMPS 183 bboard, okay? Which will be under look@fr, it will be public, and I just create a repository. Boom, this created a repository, okay? And this is the URL for the repository. Not the URL, but the Git, the SSH access code for the repository, okay? So I use GitHub, and I think Bitbucket is the same. I create a private and public SSH key pairs. I will have the private key on my laptop, and I upload the public key to GitHub. This is the way it works, okay? And if you need to create a public-private key pair, there are instructions like SSH private key create, generate. I mean, this generates also a public, okay? But generating SSH keys, okay, this gives you check if you have them, generate a new one. There is all the documentation you want, okay? I will post it on the web page, okay? But I have it already. So this is my repository, okay? This is my repository address. So now I go back here and I say git add remote. This will tell it, you know, I add a remote repository, origin, this. I hope I did it right. No. Git add. Oh yeah. Git remote add. Yes. It's always, you know, do you a chicken want? Yes. So now I've added it. Okay. And so git remote. I have a remote that is called origin. Git remote verbose. This tells me that I now have defined a repository called origin. Origin is the traditional name that is at this address. And it's used both to fetch new code and to push my changes, okay? So that's how you add it, okay? Now, once you've done this, I can do git branch, and this tells me, well, I have a branch called master. Great. Git push origin master. This pushes my branch master to origin. Let's see whether it works. I'm not sure it does. Let's see. Yep, it did actually. Okay. So now my code is there, is on GitHub, and if I go to this repository, you know, there I can see all my files. So one of the very nice things that people use GitHub a lot. I'm sure that Bitbucket works as well, by the way. And I you know, I don't have preference myself, but suppose there is a line of code. You know, I can go here. So let me magnify the code. And for example, suppose I want to tell you, look, you know, this you need to fix. I can click on the line number. It gets added to the URL. Okay. At this point, if I have this URL, I can email it to you. And this is a pointer to a particular line of code. Very, very useful to work with others, okay? If I cut and paste this URL and go there, boom, okay? So it's incredibly useful to collaborate this kind of feature, okay? So now my code is all on GitHub, okay? Let me see where I am. Sorry, a bit of confusion. Here. This is a repository. Let me close this window. Okay, and I can browse the code as much as I want. I can, you know, it's a little bit, I can look at the various branches. It's little bit primordial. I wish it had a better way to visualize what's going on. But, you know, whatever. We will use it in more interesting ways soon, okay? So now, just to give an example, imagine that I actually need to do some work there. Sorry. How do I do this? I'm here, and if I ask git branch, well, I'm in the branch master. Okay. Now I want to work in the branch Luca, okay? So how do I create a branch Luca? Git checkout -b Luca. This will create a new branch Luca. I mean, these comments are a bit, you know, black magic. I will give you a link to a Git primer, but you know, I think it's a silly name. It should be like a Git branch create Luca, perhaps, okay, or something like that. But it's called in this way because of some logic it has, okay? So now I do this, and I switch to a new branch Luca. If I do git branch, it tells me that I'm a Luca, and if I do my beloved git k, here I am. It tells me that there is a Luca and a master branch that they coincide. Okay, they're in the same place. Great. Now I have a branch, and I can do my change. And to do my change, I think here I still have my my editor. One of these, yes, this one. Okay. So, you know, here we are in the bboard app. So I can make a change. Let me make some change that is not so important. Like mail setting sender, I want this to be like luca@ucsc.edu. Okay, that will be my change to send email. I don't know, it's just a completely silly change just to do one quickly, okay? Then at this point, I need to commit my change, and so I may want to do git branch to be reminded that I'm in Luca, git commit -a, but actually here it tells me that the change is on branch Luca, and so fixed email address, okay? So this got it, this did it, okay? And if I look at git k, I have to say update. But you see, now there is a master branch, and ahead of one there is the Luca branch. Now I have to ask our TA, Rakshit, can you check out that repository? So let me tell you where it is. Okay, so I can, you need the URL, right?
I have it. I've pulled it.
Oh, okay, you pulled it already? Okay, make a small change. Okay, so in your own branch Rakshit, so we show them how the common way to work. Make your change in a branch called Rakshit and push it back. So just a moment. Sorry? Yeah, git checkout -b Rakshit, and then you do a commit in that branch. I'll then post a primer, but I think a live demo is somewhat more entertaining. Just change, you know, a comment, whatever, one of these things that.
Okay. Added a comment.
Okay. Okay. Push there.
Commit.
Push. Git push origin Rakshit. Okay. So this is the point in which I say, hey, you know, have you done with that change? No. I mean, yes. Yeah. Does it work? Eh? I can pretend I'm you and do it otherwise. Tell me if it takes longer. Oh, because I haven't added you as collaborator, probably. Right. Right, there is this step that, you know, he cannot push to my repository. He can fork it, but he cannot push. So I have to go here. Oh, very good. I have to go to settings for this repository. No, not my general settings. The settings for this repository. Yeah, and I have to collaborators, and I have to add him. Oh, confirm my password. Let me pretend I'm him, because you, of course, believe that I remember my GitHub password, but I don't. Yeah. No, it's my fault. Okay, so now I will pretend I'm Rakshit. So how do I? What was Rakshit trying to do? Okay, he was trying to do this, and I'll do it exactly what he's trying to do, but in another directory. Okay, so you see, this is the clone URL of a repository. This is what you have to email to each other. So you do this. You go here. I open another window. Okay, in this terminal, and I do this. I go to my Scratch space, and I do git clone, and then I give the repository name. This URL that you find on GitHub, okay? So this will fetch a copy of the repository. Done, okay. Now I say git checkout branch rack sheet. I hope you don't mind. Okay. Sorry, I need to go to that repository. Okay, now I can do it. Okay, now I'm in a branch rack sheet, in a different directory entirely. Okay, now I do a small change. I use nano just to be fast, and I can do modules, db.py. Okay, let's use tables.py. Okay, for example, I don't know. This is the main table containing the posts. Okay, so I just added this comment. Fine, it doesn't really matter what I do. Okay, now I can do git commit -a, and this will, look for all the changes to any file that was ever added and commit them. So you see, the file modified is modestables.a, added a comment to the db defs. Okay, now I have this change in the rack sheet branch, and I can say git push origin rack sheet. Done. And this pushed it. Okay, so now if I go to GitHub, and I refresh this page, okay, you see there is a branch master, but also a branch rack sheet. There is no branch lookup because I forgot to push it. Okay, the branch lookup, if I want to push it, I have to go here and say git push. Sorry, I was getting some garbage. Git push origin lookup, so I can also push it. Okay, but now essentially what I want to do from here is actually get his change. So what do I do? There are various ways of working, and I tell you the way I work because I think it's the best, obviously. Otherwise, I would use another way, right? So I do git fetch. Git fetch does not modify the state of anything I'm actually doing. It just fetches what other people have done, but it keeps it aside. And this is why I like it. I like very much, I don't like to break my code if other people make mistakes. I just like to do things in stages very slowly. So I do git fetch. Git fetch looks for changes in the repository, and so this is the only thing that confuses people a lot about Git. That is, let me do another drawing for the people here who are following live. So if he makes a change, I will get his change in a branch called origin. Well, maybe I can just show you here. Okay. So now I do git branch -a. This will show me all branches. I have a Luca branch, a master branch, and then I have a remote origin Luca, remote origin master, remote origin rack sheet. These are branches that I don't have a copy on my I mean, I have a copy, but they're not in my directory. These are essentially things that get fetched from other places. Okay, and I can go examine if I want. Okay, so. But the change that he did is so far kept separate from my changes. Okay, my changes are totally unaffected so far. And if I go here to my git-k and I do an update, you see that there is master, and then it branches into Luca and remote origin rack sheet. And so what I do typically, if he tells me that he's done, is that I will go and I will click on master, double click on here rack sheet, and I will say differ from selected to these. Okay, and this will give me the difference that he did. I'm sorry I cannot enlarge the font, but this says this is the main table. I mean, I can see that the change he did. Okay, the other thing you can do is do a pull request on GitHub. So if you are in the branch rack sheet, okay, I can create a pull request, and I can say, please merge. I tested it. Also because it's there is, and I can create a pull request. A pull request is this GitHub way of saying, hey, I think you should actually merge this into master. And the only beautiful thing that that it has is that I can go look at the files changed, and I can make silly comments on them. Like I can, for example, click here and add a comment that says, good. No? And I mean, typically you don't say good, but you typically you say, hey, no, you should do this another way, okay? And otherwise you say that everything looks fine to you, okay? So I find GitHub, and Bitbucket must work in a similar way, but I'm more familiar with GitHub. I find GitHub very useful in order to do these code reviews to people, because what you want to do is not merge blindly in your work what other people do. Okay, the beauty of Git is that it enables you to work with a little bit of care in what other people do, so that you avoid the code being always broken by mistakes that others do. I mean, you make mistakes as well, but your mistakes, you know how to fix them. If I get a mistake in some code, that somebody else wrote, I may not be so happy because it's more of a pain to fix. Okay, so now I am in this state. I can also run his code. How do I run his code? I have to say git branch, git checkout rack sheet. This will create a local branch rack sheet that tracks his remote one. So if I look at the list of branches, now I'm in the branch rack sheet, and if I look here, okay, file update, you see that I'm in a branch rack sheet. So the difference is that rack sheet now is an actual branch that I have on my directory. My directory tree is the same as he committed. Actually, I committed by fucking, but essentially, let's pretend this him. Now the rack sheet like that is the same snapshot that he committed. Remote origin rack sheet is a branch I can examine, but I don't actually have it in my directory tree. That's the difference between the origin branches and your local branches. Okay, when you do a fetch, you update these branches that have remote origin in front of them. So you update the branches you can examine, but you're not modifying the code in your own directory. And this is something that I actually like a lot, because I never want to modify what I have in my own directory before I have a chance to examine what other people have done, okay? So now, I look at his code and I think, okay, great. But I want to merge it into master. I don't want to merge it into Luca, no? Because, I mean, I could also merge it into Luca, but typically I might want to merge it into master. So what is the problem? That normally I work in the branch Luca. So how do I merge stuff into master? Well, I do this. I do git checkout master, okay? Git merge origin rack sheet. Okay, this merges his change into the master branch. Okay, and there was no trouble. In fact, the merge is called as a fast forward because he simply got changes he did that were not in master. There was no, merging of incompatible things possible. And now I have a new master branch, and now I need to push it to the shared repository so that he can look at it again. And so I do git push origin master. And this will put the branch back in the repository. Okay, now if I look at the situation, I can see that master and rack sheet coincide with what is on the server. So the remote origin branches are meant to represent what's on the shared server. Okay, now, okay, then I want to continue working. What do? I do git checkout Luca. So I go to my own branch Luca. Sorry, git checkout Luca. Okay, now I'm in the branch Luca. Great, fantastic. And I want to merge what he did also into Luca, because I don't want, I also like to have this change now that I like it in my own branch. So I do git merge. I don't know. I can do git merge master, for instance. Now this is a real merge because I'm merging two possibly incompatible changes, but actually we touch the different files. So I need to write a commit message, okay? And then if I want, I can do git push remote origin Luca. Even though this is not really very necessary unless I want him to look at my code, okay? So if I look now at the state of the branches, you see that there is Luca that is the merge of the change I did and the change Rakshit did. Unfortunately, I'm always the author because, you know, I was faking it. You know, I was acting as if I was him. But otherwise, it would tell me the name of the person who did the change. Okay? So this is a quick primer. And I think, you know, probably to you the reaction, I mean, I'll put a primer on the website. I think the reaction of many of you must be, my goodness, isn't it easier to use Dropbox? Actually, no, yes. So it's easier at the beginning, and it's incredibly easier to shoot yourself in the foot. Because suppose I do some changes to a file that takes me some time to do. Then he does an incompatible change, and then, you know, either I'm careless and he overwrites it and I don't realize it and I then lose my change because, you know, I forget about it, or the two changes don't get merged. So essentially using Dropbox is cheaper at the beginning, but it's a recipe for disaster in the long run. And moreover, I repeat it, when you go out in the job market, for those of you who want to go in the job market, Git is an essential skill. Nobody nowadays develops without versioning code, and Git is by far the most common way to version it. There are some people that, you know, for the interview ask you, okay, so what's your GitHub repository name, so that, you know, we can borrow some of the code you wrote. And I'm not making it up. This happens in many interviews. People want to see which code you wrote, so that they can, you know, see if your code is readable and well done. Okay, so in a way, you know, you build a reputation by building these pieces of code and showing people that you can contribute. For example, you know, one thing you may want to consider doing if you have something you like is pick a project you like that somebody else is doing, download the code, contribute to it, and ask people to merge your changes if they're useful. Okay, I mean, when you go for an interview, because, you know, it's hard to. You may look great on paper, but, you know, how do I know that you write half decent code? Okay, either I ask you to write some on the whiteboard, or if you come there and you say, you know, I implemented this huge thing there, then I will read your code and we'll get a much better impression of who you are and how you write your code. Okay, so this is something that is really done, and so I think it's important that you master it, even though you might consider it a little bit boring. It's boring, but you need it. It's, you know, like carpenters' basic skills that they need to be able to cut these, you know, wood joints in the right ways. Okay, I'll put a primer, but otherwise I think I spent enough time on Git. Any questions so far? Yes?
If we're working on multiple machines on the same project, how do we effectively flow the repository onto, like, say I want to work on a new machine and I want
it's incredibly easy. You know, before I started working all on my laptop, I used to do that all the time because when I had a desktop at UCSC. So essentially, you clone the repository on both machines, right? And so imagine me, you know, about to go home. I would say git push origin Luca, and this would push my branch Luca to the repository. Okay, then I would drive home, and once home, I would, you know, go to my home desktop and I would say git fetch, git merge Luca, git merge origin Luca, and this would merge the branches of origin Luca in my directory there.
I'm talking about, like, a fresh copy. I never used this machine before where I, like, starting now.
Oh yeah, you say git clone and then you do that URL.
Okay, but just like getting them to Python.
Yeah. So your point is, you know, what do we have to version? Actually, this is a very good question. So what is it that I'm versioning is your question fundamentally, I think. What I'm versioning is this. Look at where I am. I am in this place. I mean, don't look at the prefix. The prefix depends on where it is. But in the applications directory, I have all my applications, okay? And I'm versioning not Web2Py, but I'm versioning my single application. So if I'm developing bboard, I'm inside the bboard directory, and there is where I created my repository. And I created my repository with git init. This creates an empty repository, okay? I can do it in another directory for you. I can do like a temp. Hold on, So now I'm in my temp directory, okay, and I can like make dir foo, cd foo, okay. I can like attach blah.py, okay. Now I can do git init. This creates a repository here. It's empty. Now I can say git add dot. This will add every file in this directory. Now this is in general a silly idea because before you may want to create a git ignore file, and you want to say don't put in any back file, don't put in any file that begins with tilde, and don't put in any, I don't know, binary file, you know? You say these are files you shouldn't try to put in. But then I can say git add dot, git commit a, and this is initial commit. Done. I have a repository in this directory. Okay? Does this help? And then you know, you need, but this is only when you create the first repository. If instead I want to clone that, I see like I can simply say okay, make the blah. I can simply say git clone. Oops. Git clone. No, I have the wrong thing in my cut and paste buffer. Where was it? Hang on. You know, if I get in another directory, I install Web2Py, I go to the proper place, I go into my application directory. Let me do a better example. You know, I'm in some place. There will be an applications directory for Web2Py. I go to it, okay, and I say git clone of the bboard application. Boom, and this will clone it. And now it will be inside my applications directory.
I did that like just like 5 minutes ago, but I didn't see the application.
Yeah.
Existing. Like, is there anything else I can do?
Well, you need to refresh Web2Py. I mean, you need to reload it, I guess, right? I mean, that's obvious that you need to reload it. But if it still doesn't work after reloading, then there must be something more complex. But essentially, Web2Py does not have a separate structure that tells it which applications exist. Web2Py simply believes that all the directories under the applications directory correspond to Web2Py applications, okay, and just lets you use them, okay? So you can have malformed applications, in which case they may not run, but you should still see them as far as I know. Okay, and if this doesn't happen, let me know and we will take it offline because I need to look at it. Okay. Other questions? Yeah?
How do we open the WP files?
Yes, you don't. There was a message on that on Piazza. So the W2P files, well, if you want to look into it, I think they are tar gzip files. But you leave them alone, okay? When you're in Web2Py, Web2Py knows how to load them, and you just load the WTP file. You don't try to open it in any way. So what you do is this. You go inside Web2Py. This is my, where is it? I don't have it. Oh, I have it here, sorry. I opened it under Firefox. So this is Web2Py, okay? And to load a WTP file, you say application name like bboard copy, okay? Then I tell it which package to upload. It will be in downloads, one of these things here, okay? This one, okay? Is a I tell it to take this file and I can say install. Session expired. Okay, fine, great. Stupid thing. You could tell me before. Well, no, you could not tell me before. Well, okay, fine. Okay. Oh, invalid application name because it contains a dash. Somewhat silly restriction. Okay. Yes, sorry. Okay, fine. It's there. Okay, so that's how you do. You don't try to look into them. And when you package a Web2Py app, this packages not only the application but also the data. So this is very good because if you want to give me your homework with a few filled-in things in a bulletin board is very nice. This is bad if you happen to insert extremely silly data that then you don't want, you're ashamed of. So limit the silliness of what you enter as data. I mean, because your data is packaged together with your app. Okay, so that's one of the things to know. So that's it. Any other question or yeah? Sorry. Just the WTP package, yes. So just upload the WTP package as it comes. So it's very easy for other people to install it. It's a single essentially click. Yeah. Yeah, that's one of the reasons I like Web2Py. With other frameworks, especially in teaching, with other frameworks, it's incredibly messy. If I were building in Django, for me to pack you a thing in Django in such a way that you can put it on your laptop and just run it without any glitch. And instead in Web2Py, it works really well, which I think is fantastic for a class. So that was one of the... more questions? Okay. Okay. So I'll do, by the way, something on HTML, but I'll do it after I talk a bit about databases. I mean, I have to do things in some order, and so I chose some order. One note before I move to databases. I created a spreadsheet for projects, and some of you have already added the project documents. On some of them I commented, on some of them, I was away for the long weekend for some of it, and so I didn't add any comments. But I really would like every one of you to have a project proposal that can be very short. It can be even 2 paragraphs. You can tell me what you want to do, and so I can comment on it, and I can start giving you feedback, okay? You create one entry in the spreadsheet, and you give me permission to comment on your Google Doc, okay? And I will comment and give you feedback in that way. You can give it both to me and to the TA. And then I would like that the people who are hunting for how to call the project collaborators, that they give a short presentation sometime next week about what they want to do in the project, so that other people might get interested in the project and join them. How many of you are like undecided about the group you want to work in? Raise your hand if you don't know yet, just to get some measure of how many people don't know. Yeah, don't know. Raise your hand if you haven't decided exactly, or if you're looking for people, or if you're looking for projects, essentially. Yeah, either. Okay, so a fair number, yes. So I would like to do this as a way for people to, there are people who have like a great coding skills, but they in that moment they feel happy and they don't know exactly what project to do, and vice versa, right? If you do a project, it also helps to have a sort of complementary skills. For example, if I were to do a project, I would certainly look for somebody who can actually make things that look pretty. So that can do a little bit of visual design in addition to what to do. Okay, and so for example, you may say, I want to do a project that enables people to embed a Google Chat inside a site for collaboration. So okay, I think I know how to use a Google API to implement Google Chat, and the other person will do the rest of the pages, or something like that. So it helps to have some idea about how you want to divide the work. That might be a good. Okay. Okay. So let me go on databases. So why do you use a database? There are various reasons. One is data persistency. You want some data at least, to be there after some time. Okay. Of course, the file system also offers persistency, and in fact, databases are implemented on top of file systems. But databases are one way to get it. Another thing that they give you is data replication. If you are doing a slightly serious application, you don't want to have a database only, because then if the database dies or crashes or something happens to it, to the machine that hosts it, then you have no database. But databases know how to replicate themselves. For example, I can say, okay, fine, I create 3 databases. One is the active copy, and then there are 2 replicas. And these replicas, you can define what happens. So these replicas, for example, you can say, whenever the master copy changes, they also are changed. They also are updated. But otherwise, they just stay dormant. They're not used to answer any query, but they just are copies. So if my main copy dies, because say that machine, the disk crashes or whatever, you can, in a very small amount of time, under a minute, if you configure it well, a few seconds, you can take one of these secondary copies and you can declare, oh, okay, now that's the master. And then, slowly in the background, you build one more copy so that you always have 3, okay? The databases help you to replicate your information, to do this kind of tricks. You can also make replicas so that you can read from either the master copy, or if you are okay with the slightly out-of-date information, you can read from one of the replicas. Wikipedia does that. Wikipedia has a lot of traffic, so it has a master database, but then it has read replicas, because most people just read the Wikipedia, they don't write it. So if you just want to know, hey, what's the last revision of the Obama page? You don't need to ask the main database. You can now ask one of the replicas that are kept in sync, and the replica, will answer you so that you can divide the load, okay? So data persistency, data replication, and the most important is, oops, sorry, this goes on when I click, is manage concurrency. So I don't know how many of you have taken operating systems, but it's usually hard. It's very hard if you have to do it yourself to manage the fact that there can be many people at the same time contacting the different web servers, and the different web servers are trying to modify the same database. The classical example used to be, an airline reservation system, except now they do overbooking, so they may care less, but I think they still care. So, you buy seats for a concert, right? You want to be able to say that, seats 1, 2, 3, 4, now I want to buy them. And so I have to first query which seats are available, and then I have to mark them as sold. And in the meantime, another person could be doing a similar transaction because they also want to sit there, right? And so there will be these 2 people, these 2 web accesses, within the same access. So suppose you're looking at your screen that says, do you like these seats? 1, 2, 3, 4, now in the whole auditorium. Yeah, you marked them, and at some point you say buy, no? You commit to buy them. What does that commit to buy do? How does it work? I don't know, but typically you may want to say that you read if 1 to 4 are free, okay, and then you write that they are sold. This is a very simple and typical thing that you might want to might want to do. You need to first check that they're free, because otherwise you give an error to the user saying, I'm sorry, but while you were sitting idly staring at the terminal, somebody else bought them before you. No? Well, okay, maybe you want to give a different message, but you can. I serve you a page telling you that the seats are available. And maybe, if I'm very kind, I might reserve them for a minute while you stare at them. But I don't want to reserve them forever, because, maybe you go out for dinner, and I want to be able to sell them to other people, right? So in general, when you commit to buy them, I have to check that they're still free. So, and the other person will do the same. Read, okay, and write. Read and write. And so, if you have taken operating systems, you know very well that if you don't enforce any kind of synchronization, bad things can happen. You can read that they're free. The other person can read that they're free. Okay, you'll mark them as taken. The other person marks them as taken as well. Okay, so in the end, they're marked as taken. But essentially, I believe that they were free for both of you, and so I will give you an answer in the browser so that both of you can print the same tickets for the same show. Okay, and then you show up, and you have the same seats. Okay, so this doesn't work. So when you need to enforce consistency, and I will spend some time, between concurrent accesses, databases help you do that. So they manage essentially all the difficult parts. That is why in databases are extremely important and popular for web applications, because they manage essentially the shared state in a way that keeps it consistent, replicated and stable. So they're essentially fundamental, okay, to this type of web design. Okay. So now there are many databases types. So there are two that are most common, and I will describe a bit in these lectures. So one is relational databases. How many of you are taking classes or know what relational databases are? Raise your hand if you do, if you know. Wow, very few. You should all know. I'll tell you the basics of relational databases. But essentially, relational databases are very powerful, and they keep information organized in tables that can relate to each other. No, one of these bulletin board thingies we created is a table of a relational database, essentially. Then there are non-relational databases or NoSQL databases, which have in common the fact that they are not relational databases, and there is quite a wide variety of ways in which they work. Okay. One of the most common, so some of the common ones that you hear the names are MongoDB, Google Bigtable, the Google Data Store, etc. Many of them have a very simple structure at the basis. Maybe they have additional features to them, but many of them implement key value mappings. So you can have a key and a value. The key is, generally a string. And the value can be anything. It can be even a fairly large object. Okay, and so the advantages of NoSQL databases is that they can be cheaper for very much larger sizes. So in general, relational databases are happy when they store the relation and the interconnections between concepts. I will give you examples, but they are happier if they are small. Okay, the Wikipedia one is an exception. It must have like 1 billion rows or something like that. But essentially, these databases work better when the amount of storage they use is small. It's also somewhat expensive to use very large amount of storage for these databases. Okay, and because they manage concurrency, there is an upper limit to how many concurrent simultaneous transactions per second you can manage in a relational database without starting to spend a huge amount of money. Okay, for example, a typical MySQL server might be able to connect to 100 or 200 simultaneous web servers, and it might be able to handle between 10 or 20 simultaneous transactions. This sounds like a lot, but it's not a lot. I mean, if you do a startup that wants to scale, this is not very much. Okay, so Twitter is using a relational database, and my intuition is that that's part of the reason why it was crashing all the time. You haven't heard me saying this, okay? But I believe that it has something to do with that. Wikipedia never crashed; it was always very stable. But some MySQL was following the Wikipedia as a showcase of how well MySQL worked, and they had some absolutely top developers of MySQL that were babysitting the Wikipedia databases. Yes.
In terms of performance, does it make a difference what proportion are reads versus writes?
Yes, so I mean, I can give you very detailed numbers on these things. Maybe I should give them later after I say what relational databases are in general, right? Because it will make sort of a little bit more sense what I say. Okay, but ask me this question again after I describe somewhat what the typical performance is. Okay, but so for the moment, think at them this way, and I will give you more comments about relational databases. Lots of interconnected data, but not very large if you can. Non-relational databases, key value mappings, so maybe you can have indices as well, but essentially this is distributed. It can be scaled to extremely large sizes and extremely large amount of readers and writers, okay? But you don't have, but you give up on the consistency and on the richness of query types that you can do in a relational database. So let me go on, and then this will be clearer, okay? So in a relational database, so I give you the intuitive definitions. You know, there is one Chutan teaching a nice class in which she does all the, you know, proper thing about relational algebra. I give you a crash course. So imagine a relational database as a collection of tables. Okay, every table, much like a spreadsheet table, has columns. The elements of each column have a type. Okay, and the databases typically support at least integer, float, date, and string of some kind. Okay, then you know, every database has slightly different data types supported, but those are, you know, the universal ones. Okay, so typically, and in most cases in Web2Py, every row will have a special, every table will have a special column, the first one, that is called ID. And that will be an integer that will be auto-increment, meaning that you don't have to worry about that ID. It will be assigned automatically. Every time you insert a new row, it will get a subsequent integer. Okay? So every row has a unique ID. This is actually not required, but it's so common that it's as if it were. You know, don't worry, it will always be there, the ID. And if you don't want to pay attention to it, just don't pay attention to it. Okay? Now you have a lot of rows, and you need to, I mean, the interesting thing is to read back data in some ways. So for example, you can say, hey, tell me everybody that has a name, that has the email john@ucsc.edu. Okay, or tell me everybody who has been here for at least 6 quarters has a GPA of at least 3.2. No, these are things you can do. So in a relational database, you can ask any question of like this, and it will give you an answer. But unless it has an index, it would have to read all the table to be sure that it gives you the full answer. Okay, so suppose you create a table without any indices, it will work perfectly, except it might be really slow if you have a lot of data. If you know which kind of queries you are going to do it, if you know how you are going to retrieve information, you say, hey, put an index on the email. And then you can do queries like, give me everybody whose email is john@ucsc.edu. Or you can say, give me an index both on number of quarters and the GPA. Okay, and then you can do queries that involve those. Okay, I need to tell you something more about indices, because there is a notion of how to create them in the right way. Okay, so the beauty of a relational database is that you have a language called SQL, SQL query language, that enables you to write queries in a way that is essentially portable from among many databases. So the commands to create tables are not necessarily common between the various relational databases such as MySQL, Postgres, DB2, and you know, Oracle DB and whatever else. But the SQL statements to do queries are essentially portable. Okay. And I give them to you by example. You don't have to write them in Web2Py, because Web2Py has its own way to do queries that we will go over, okay? But this is just for your knowledge. You know, you could connect to a database and you could write these queries like this. For example, you can say, select name and email from students. And this would give you all the names and emails from students. I wonder, is there a database that I can use? I should have prepared the one. I mean, I have the code together, but it's full of confidential data. Sorry? Yeah, but actually, I can use the one from my bulletin board. Okay, so this may be a more useful example for you. So let me go to the bulletin board application. If I see, if I do you see there is this databases directory. I can go there, okay, and there is this storage.sqlite. That's my database. So I can say sqlite3 storage.sqlite. Okay, this accesses the database, and except that I forgot all the SQLite comments. Show tables. No, I think it's called tables. Yeah, dot tables gives me the list of tables. So there is a table called bboard, and then I can say describe a bboard. No, it's not describe. It's schema bboard. I'm sorry. These are all different from database to database. How do I find the form describe an SQL table? Dot. Yeah. Okay. Thank you. Oh, show bboard. I think it is. No, it's not show. Schema bboard must be. Yeah, schema bboard, sorry. Schema bboard tells me the structure of a table, okay? And now I can say whatever I want. SQL works the same. So I can select name from bboard. This will select all the names. Okay, fine. Select name and phone from bboard. This will select both of the names and the phones. It uses this like separator there. It's not very readable, but it's very compact. Okay, and then I can say, for example, select name phone from bboard where name where email is equal to luca@ucsc.edu. I think there are some data like this. Okay, and so, you know, this is an example of how you can query a database. Databases of this kind are incredibly useful also for other applications. Sometimes it's useful in a web server to suppose you have interesting information such as, you know, who are the people connecting, you know, and you gather some statistics. You gather them for a month, and then you can start exploring your data. For example, you can say, select, you know, I could say in CrowdGrader, select the users where, and I can write a query that says count of the assignments they created is above 10. This would, you know, give me a list of everybody who is like a dedicated user to CrowdGrader. You know, you can do these queries on the fly, and they're very useful. Okay, so yes.
What was the first command you entered to get into that? It was SQLite, all of my what?
SQLite 3. It's just, you know, the command. I believe it comes with Anaconda. Okay, and that's one of the reasons I advised about to use Anaconda. But I think it's part of that install.
Separately also not installing Anaconda and just installing Python or Python 3.
Yeah. Yeah, but it might be there anyway. Yeah, it's very common. Check that you have it. It's very easy and handy also for debugging your web app, obviously, right? You can go and look what's in the database directly. So I use it a lot in that sense. So back to the demonstration, back to the talk. Now, this query that I say, select the name and email from students who have GPAs greater than 3.5. What I do is this in Web2Py. I say DB, and then I write the query, DB students GPA. This is a GPA table column of students, and then I write the query, select, and I can say which rows I want. But the general SQL syntax always works. So this is more examples of queries. You can essentially the form is a select, and then you have the list of fields from, and you say which table, where, and you say the conditions on that particular table. And you can also say in which order things should be retrieved. Order by GPA descending. Limit 10 tells you that you want to obtain at most 10 rows. Okay. These are kind of things that are very common to do. You can also select a count of a number of rows. For example, to check, you know, whether Luca is a user of your system, you could do select count from bboard where email is equal to luca@ucsc.edu. Okay, and this tells you that there are 3 rows. And you know, selecting a count is faster than actually retrieving the 3 rows, because it can be done directly from the index without having to read the rows. Okay, so as much as you can, you know, you should try to get the minimal information from the database you actually need. You shouldn't try to get too much. Okay. You can insert data. Okay, and this is the syntax of an SQL insert. We will be using a different syntax in Web2Py, but you can insert the data directly in SQL. You say insert into students, and then you give the name of the columns for which you are providing values, and then you provide the values. Okay, so there is a way to insert data in SQL if you wanted. There is a way to do an update if you wanted. Okay. I will be going over these statements in Web2Py. So these I put them in this presentation basically for your reference. Oh, by the way, and if you want to know more of these commands, what do? You do these. Sorry, I need a new browser window. But for example, you can look at the MySQL documentation very easily. MySQL insert. Okay, insert syntax MySQL, okay, and it tells you everything you can possibly do. MySQL is a very common database to use. Postgres, you know, is another common one, and you could look for that. Okay, but again, we will be basically using the interface to databases given to us from Web2Py in this class. Okay, what is a foreign key? So let me do this by example. So don't look at anything except at the table. So sometimes I put too many words in a slide, but I just want you to look at the table and not at any words, okay? So fine, suppose I build a table like this. There is the name of a student, there is the email, number of quarters, GPA, and major. Fine, this is perfect, okay? This table works and it sort of serves its purpose. Now, suppose I want to have also the name of the major director. You know, the major, I don't know, a student advisor. No, for each major, I want to put it also in the table. Okay, for some reason, it's just an example. But suppose I want to do that. So for everybody that has a CS as major, I would have to put a name. I made up a name, but I would have to put the name in this table. Okay. Now this is a bad organization of a table. So essentially, if you build a database, you should check that there is the binose criterion is this. If something changes in the real world, make sure that there is only one place that should be changed in the database. Or say it in another way, make sure that there are no like constraints between two different places in the database that have to be in a certain relation, otherwise things break. Let me say it just informally for the moment. For example, in this organization, this Hugo person here appears cited twice. So suppose that now Hugo goes away and, you know, Helen comes in as the new advisor or major director, and they have to put her for everybody in CS. I would have to update all the Hugo into all Helen. Okay, that's something that you typically want to avoid. Okay, in fact, there is a big theory if you take the theory database classes about how to define these unwanted correspondences and how to avoid them. But I think that intuitively, the idea is different rows should be fairly independent. Okay, you should not have a constraint that says, hey, if everybody in CS should have this shared information. If that's true, you should put that information somewhere else. Essentially, there is a bit of a conceptual error in designing a database like this, because the information on the major director is associated to the major, not with the student. So you're replicating it because you don't have another place where to write it. But what you should do is create another place where to write it. And so what you should do is that you should create two tables, one for students and one for majors. Okay? And in the table for students, you simply put a pointer to the major in which they are. Okay? So you simply have a major ID that contains the ID of the row where the major is described. And then the major has, you know, the name and the director. So there is no replicated information. You see, in this table, if the director of the computer science changes from Hugo to Helen, I would have to change exactly only one place, and everything would be fine after that, okay? And if a student changes major, I would only have to change, I would only have to change this particular piece of data, okay? Now, these numbers here, this major ID is called a foreign key. That, to me, it always appeared like a mysterious and scary name. But what it means is that these 1, 2, 2, they are keys into other tables. So they're essentially the IDs inside other tables. And these things are very easy to create in Web2Py. But the difficult thing to do is to remember one thing. What happens if you delete data? So for example, what happens if you delete the computer science major? Okay, maybe because you want to rename it. Suppose, you know, one day we merge with computer engineering and now we have only the CSE major or whatever it might be called, okay? So I'm deleting the computer science major because I'm adding another one. What happens to the students that have chosen computer science as their major? Okay, there are two behaviors that in databases are called onDelete cascade and onDelete set null. I think there is another one as well, but I don't remember it. But these are the two most common. The problem is that in many frameworks, including Web2Py, the default is onDelete cascade. So if you delete the computer science major, the database would also, without telling you anything, automatically delete all the students that have CS as their major, which might not be the wanted consequence of the deletion, right? So this is a gotcha. We have to remember that we always have to choose one of the two, and choose it carefully, because in some cases what you want is delete set null. The two behaviors are like this. Suppose I deleted the computer science major. onDelete cascade would delete all the CS students, because it cannot leave the major field null, and so it deletes them. If you say onDelete set null, the students that used to be in CS major would be now a null element as the major that doesn't point to anything, but they would still exist as records in the database. So this is a choice that you have to be careful about. Now, how can you... so the beauty of relational databases is that you can do queries that traverse more than one table. And this is a way to do them. Suppose I want the students that have a student ID of 1, but I want the whole data for the student that has a student ID of 1. I can say, select the student name, major name from students. So I will have the student name, but also the major name. From student join majors, so from the join of these two tables, from the union of these two tables, where the constraints are that I want that the student major ID is equal to major's ID. So I enforce this equality constraint explicitly, okay? And the student ID is equal to 1. So this will give me the full data on the student John. Okay. This is a good way to represent, for example, when many students belong to a single major. Or, for example, when I have, I have to make a database of, I have a blog on which people can comment, and I can have many comments that refer to the same blog post. Every comment will contain the ID of the blog post to which it refers. Okay, so now I want to design that. Actually, maybe let me first design the tables for a blog in Web2Py. Okay, so that we are able to. I mix some examples to some theory. Let me do these. I can do blog. I create a new app called blog, okay? And let me see, maybe I can even edit it with these. I think I can. Yes, here it is. So I can go here, I can go into models, db.py. I can create here a new file that is tables.py. Okay, db define table. So let's define a blog a moment. Okay, how does a blog work? A blog with comments. So there will be many posts. Okay, and every post can have comments. So what do I do? This will be a post table, okay, and I will just define some field post content. Maybe Rakshit, can you check my syntax that that is sort of somewhat reasonable text? Maybe field is field that I have to use. I think so. Well, let me look in the other table. Do I still have them? Yeah. Yeah. Okay. Fine. I was doing it right. I forget a lot of the syntax, unfortunately. Fine. So field the title. Okay. And post content, and then we could use an author field, yeah, whatever. But let's just leave it to these two fields for the moment. Okay. Now I want to define another table that will contain the comments. Okay. So the comment is a piece of text, okay? Now, how do I exactly say to which post does the comment refer to, okay? So I have to essentially add to the comment the foreign key to the post, okay? So, and what I do is this, field, I generally call it post ID, no? So I remember what it is. And then I have two syntaxes. The simplest one is that I can say that this is a DB post. This is a way to declare that the content of the post ID is a reference to this table. Okay, it's a foreign key to that table. Now, you could always say, and I write it here as a comment, or you can declare the type to be reference db.post as a string. This declaring it as a string is sometimes better because you have this problem of forward and backward references. Assume that you need a reference to a table that you will write later. If you say db.table, like if I switch the order of these two tables, and if I put this table after the other one, if I put it in this order, db.post would not work, right? Because the table post is defined later. And so I would get an error that, hey, db.post undefined in some various way, okay? But the other syntax always works, okay? So this is a way to organize the information into tables. So you see, I try to keep together everything that is related to a post and together everything that is related to a comment. This is exactly the same kind of split that I had between the data associated with the major and the data associated with the student itself. Okay, this is called a one-to-many or a many-to-one relation. There are many students to a major, or there are many comments to a post. Okay, now in other cases you have many-to-many relations. For example, suppose we want to keep friendships between students. Okay, how do we keep friendships between students in Web2Py and in databases? db define table student. Okay, field email, just to make an example, okay? And then there will be other fields as well, and I don't care, okay? So this is a student. And now I want to remember who is a friend of whom. Friends, okay? So how do I do it? Let me show you the slide a moment. Essentially, well, this is done for an enrollment, but it's the same. I create another table that points to the pairs of students, okay? It points to one student and to another student, and this puts them in a relation. You studied in discrete math, no? What is a relation? A relation is a set of pairs in the Cartesian product of two sets, right? And so you take, you list the elements that are in the relation, simply, okay? So the way you do it is this. You can say a field, and the names are a bit arbitrary. I can say friend one. This is a pointer, but I cannot. Is a DB student, okay? And then I can say field friend two DB student. Okay. So in this way, I can build a one-to-one relation between students. Of course, it's your, you can decide whether the ordering matters. For example, suppose that Luca and George are friends. So do you put Luca as student one and George as friend two, or vice versa? It maybe doesn't matter, right? But you decide. And the beauty of it is that you can also add other information now to their friendship. For example, you can say field when met, no? And you can say that this is a date time, okay? And so on. You could add other information about their friendship. For example, you can say field, I don't know, strength, okay? And then this is requires is equal is in set of, you know, casual, good lovers, something like that, okay? Just, you know, not to make a non-spooky example about keeping tabs on people, okay? Maybe I should delete that. Yeah, but essentially, you can add a lot of information to these things. Or for example, you know, if you want to implement some graph analysis of social networks, you can put floating point numbers all over the place, right? And define whatever you want. Okay, so yeah. Okay, and so there are ways to write joint queries for these many-to-many relations, but I think you know, we are out of time, and we will continue next time. So with defining tables and writing transactions. Yes. Sorry. The ID field is automatic. Web2Py always adds an ID field. It just does. You don't have to define it. It's added for you. Okay.